Hello, so today we will talk about some assumptions when using paired sample testing as well as some comparison of variances. So as we talk about paired t-test, I generated some data for pre and post treatment or training or something of that nature, just before and after. And I also use multiple groups for energy consumption of gas, solar, and electric. So one of the assumptions that we generally get in using paired samples is that it is normally distributed. So there are options that we use non-parametric tests when they are not normally distributed. So we should first check for that normality. So to do that, I use the Shapiro Wilks test to test for normality of the pre and post data set. And one of the beauties of Python is it allows me to build in my own logic. So here you can see if the pre p value is less than alpha or the post pre value is less than alpha, it is going to give me a warning, or I have it print a warning that the data may not be normally distributed. And then it'll advise me to use a non-parametric test. Little cheat here. As you can see, I did not use a non-parametric test. I used a paired t-test because the pre and post p-values are greater than, sorry, this is in print, right? So it threw me off a little bit. It's greater than the p-value. So we failed to reject the null hypothesis. And then we look back at the paired t-test, and here, same thing, built in some logic on the p-values. And as you can see, the paired p-value here is greater than 0.05. So we failed to reject the null hypothesis here. There is no significant difference before or after training. As we look at the comparison of variance, here the assumption is that the variance is equally spread. There's no heteroskedasticity. And hopefully I said that right. But I use the Levine test here to test for variance of the comparison of variance between each of the electric sources, the solar energy source and the gas source. And as you can see, I built in some more logic. So that p-value is less than 0.05. So we must reject the null hypothesis. There are significant difference across the heating systems. And lastly, I plotted, using a box plot, the gas, electric, and solar energy sources. If it is, the variances are equally distributed, then it should be symmetric and no outliers. And in line with what the Levine test showed us, it is not symmetric and there is indeed an outlier. So be sure and check for all of those common assumptions when you're doing your hypothesis testing.